Good afternoon and welcome to another edition of Trucks Academy Live. I'm your host, David Brown. I'm the Senior Manager of Technical Training. I'm also joined today in the studio by James Olson, who is an aftermarket reliability engineer, and Larry Miller, who is the Performance Improvement Manager for Technical Training. Today we have the distinct pleasure of presenting to all of you a revolutionary new technology that was recently introduced on our trucks. I'm talking about front active steering, or FAS. Today, we would like to take you through the design and function of the system, its components, and the calibration and repair process. But before we go any further, I just want to check in with the audience to make sure that our audio connection is strong and that you all are receiving signal. So if someone could please, in the chat box, or the question box, the question box, if you wouldn't mind, please give us confirmation that you're hearing the broadcast loud and clear. Okay, great. So thanks for joining us today for this broadcast on this extremely exciting new technology that we're adding to the trucks. And James and Larry, I have to be completely honest with you. I'm probably not as familiar with active steering as I should be. Being the Senior Manager of Technical Training, I guess one would probably expect me to know all things front active steering. Before we go too much further, James, would you mind just kind of giving us a brief overview? What is front active steering?
Is a new feature. It's designed to reduce driver fatigue. It's an overlay system, which means that it's an addition to the hydraulic steering system. It's not. It doesn't replace hydraulic. It helps, or it reduces the operation, or it helps the driver up to 85% in terms of the force required to steer the truck.
Very cool, very exciting. So it sounds like an amazing new technology. I can't wait to dig in a little more as we go through the information that we have prepared for today's presentation. The next question, I guess, that I have, and Larry, I was wondering if maybe you could expand on this a little bit, but when was front active steering technology implemented on our trucks?
We released release bulletins on Truck Dealer Portal, but to be more specific, we started releasing week 5 of 2020 on our Volvo over-the-highway products. Then the next release was for the Mack Anthem. That was week 30 of 2020. Then followed by the Granite, which was released week 47 of 2020. And the future release is going to be on our VHD models, and that will start week 5 of 2021.
Cool. Okay. So just to maybe simplify things for those of us that don't speak in weeks and years, maybe not everyone works for a vehicle manufacturer. So the Volvo product came out first at the beginning of 2020, early in the year, right? I think you said week 5 of the year. So early in the year, it was released with the Volvo Highway product. The Mack Anthem was kind of more in the middle of the year, mid 2020. And then you said the Granite, or vocational product for Mack, released week 47, and then we're looking forward to the future release on the Volvo vocational product early 2021. So essentially that means that there are trucks out there on the road today that already have this technology. So potentially a truck could show up at a dealership at any point in time, and a service technician may be asked to diagnose and repair a customer complaint on a front active steering system, because there's trucks out there right now with the technology. So if I'm a service technician and I'm in the audience listening to today's live broadcast, I'm probably wondering, how would I know if a truck is equipped with front active steering? Larry, could you take us through the identification process that a technician might utilize?
There are a couple ways to identify it. You could look in impact under components. It'll be listed in the components. You could also look in VDA and see what the truck was built with and spec'd with. But the easiest thing to do is simply open up the hood. Open up the hood, look where your gearbox normally is, and you will see the aluminum housing of the electric motor right on top of the gearbox.
I like it. I like it. So it's really that easy, right? I mean, based on the image that we just saw, probably the easiest visual identification method would just be to simply pop the hood, take a look at the steering gear assembly. If I'm seeing something there that I'm not used to normally seeing on a steering gear, like, I don't know, a large electric motor hanging off the input shaft, that tells me that the vehicle is equipped with front active steering. So fair enough, that's simple. I guess the next question that I have are, in the photograph, this thing that's on the front of the steering gear, what are the components of this new electric steering motor? What are we looking at here? James, could you elaborate on the components for us a little bit?
Sure. I mean, it's simple to see that you have FAS on a truck, but there's a lot going on here. You've got, number one, in the photo you're looking at, the diagram, is the standard hydraulic steering gear. 2 is the electric motor, which is the overlay motor for the FAS system. 3 would be your connector to the truck data link. 4 is the power, basic power to the electric motor itself. And 5 is the gateway or the onboard computer for the FAS motor.
Okay, so that doesn't look terribly complicated. So I've noticed the electric steering motor has a dedicated data link to the front active steering gateway control unit. So I'm assuming there's more components somewhere else in the truck. Could you explain for us maybe where the remainder of the components for the system are located?
Sure. On the next slide for the Mack dash, it's very similar to the Volvo, but you've got the one is the gateway control unit, ECU, that's in the truck. 2 is your instrument cluster, or your DID, where the driver will see
Kind of like
comments
the
or
display
commands.
and the messages.
Obviously, you've got your brake control unit because the FAS system uses inputs from steering angle sensor and from ABS. You've got your VECU, which in its standard location has not been moved. But then you also have the steering angle sensor, which we've had on the trucks for years, but now we use it to a greater extent with this system. Obviously, you're looking at the Mack here, but we also have
location here for the Volvo components as well, right?
And they're very similar. If you go from a Mack to a Volvo, they're going to be within inches of each other. So it doesn't change enough to confuse anybody working on the truck.
Great. So as a technician, I mean, I should be able to comfortably find all these components within the vehicle. Great. And so now that we kind of know where all the components are located in the truck, and I kind of feel like I've got a better basic understanding of how the system, of how the system is integrated into the design of the vehicle, I guess the next question on my mind is, how does the front active steering work? Larry, could you just give us a basic explanation of how this system functions?
Well, basically what we did is we mounted an electric motor before the steering gearbox, and that motor is what actually adds torque into our gearbox. We rely on the FAS control unit to control what that motor is actually doing. And it bases that off of inputs. We have some external inputs, various sensors. We also have internal inputs from the motor itself. So once our FAS makes that decision on what to do, it applies it to the motor, and that adds torque into our gearbox.
Perfect. Thank you for that. I just want to point out that during the live broadcast, you do have the capability of submitting questions by using the question box. We've already had our first question submitted, and I'm going to hold off on answering it. It's basically what happens if the electric motor fails, and I'm sure that's the $1 million question that's on everybody's mind, right? I assure you we will cover this in great detail. We're just getting started with some of the preliminary foundational learning objectives that need to be covered. We will get deeper into the details of how this system works and what will happen in the event of a failure, that's covered in great detail. So just be patient, bear with us. We will get to it momentarily. Getting back to the discussion, Larry, you mentioned some input signals that the system is utilizing, right, to make decisions. Could you tell us a little bit more, like specifically, what are the signals that the system is looking at?
We receive internal signals from two sensors that are in the motor itself. And what they measure is the torque being applied. Excuse me. Being applied. There are two of those sensors for redundancy, so it always compares the sensor readings for an accurate reading. Excuse me, please. Apologize for that. We also rely on external signals. So we're looking at a steering angle sensor, which we've been using, but like James said, now we're asking more of it. We rely on our yaw angle sensor. Again, we've also been using that, but now it is tying into our steering system. And we also get an input about our vehicle speed.
Okay, so that doesn't sound terrible to me. It looks like the system is relying on four specific input signals. And now that we kind of know which signals are internal and which signals have been identified as external, maybe this is an assumption, but I'm assuming that these external signals are possibly being given to the system via a data link of some sort. So I was wondering if you could just kind of expand on that a little bit and tell us, where do these external signals actually come from in the vehicle?
For example, if we start with our steering angle sensor, the steering angle sensor sends data to the ABS module. The ABS module then sends that data through our gateway module. All of our external components have to communicate through our gateway module. That gateway module then communicates with the FAS control unit. And the same applies with the yaw sensor. The yaw sensor communicates with the ABS. ABS communicates with the gateway to our FAS module.
Perfect. And so, as we saw in that previous slide, it also made a mention, I believe, of the redundant sensor signals that are being compared. And I guess that makes a lot of sense to me. It's a smart idea. I mean, after all, the steering system is one of the primary safety features that's on our vehicle. The steering and brakes are a major contributor to vehicle safety. Safety has to be on the mind of every commercial driver when they step into the cab of a commercial truck. As far as these signals go, the data links themselves, it seems to me that we've heard a lot about data links already just in the beginning of this conversation. And I feel like on today's trucks, things are getting to be, the electronic architecture is getting to be a lot more complex. We're starting to see a lot more data link circuits being integrated into the electronic architecture of the truck. And so, James, I wanted to kind of throw this question your way. I was wondering if you could maybe identify for us specifically which data links does the front active steering system use?
Yeah, the FAS control unit, which is the unit on the motor itself, that communicates to the gateway via a dedicated data link. But then the gateway connects through two separate ones, the DL1, which is your 1939, but which also communicates with the ABS module. And then it's also connected through the DL2. So it's redundancy on its data links as well, where the 2284 does not connect directly to the ABS unit.
Perfect. And so I believe at this point, I guess I'd like to pause momentarily to see if anybody in the audience has any questions about any of the items that we've discussed already in today's presentation. So we do have a question from the audience. It's been asked, will the front active steering system protect or prevent maybe in some way a vehicle rollover? So vehicle stability, does it contribute to vehicle stability?
Sure, the FAS being connected to the yaw rate sensor and the other sensors that we mentioned, the external signals, it has as much input into rollover situations, steering, braking, etc. It's not going to steer the truck for the driver because this is an overlay system, but it's going to add inputs through the ABS controller, which will help with stability, braking functions, of course, and acceleration functions. So it'll help in that way, but it's not going to directly steer a truck out of a rollover situation.
Perfect. So it still requires input from the driver, right? The driver is still very much in control of the vehicle. The system is really just designed to help the driver, right, and enhance their ability to maneuver the vehicle, right?
Right. I can't emphasize enough that the electric FAS motor is an overlay system. It helps the hydraulic standard steering of a truck. I mean, you still have standard hydraulic steering that you've had forever on the truck. This just helps in more of a creature feature for a driver to help him in wind load conditions, etc., things like that. It's not an autonomous feature in any way yet.
Yeah, so you bring up wind, right? High winds when vehicles are traveling on the interstate. A lot of times you've got the broadside of a trailer. Maybe winds are, creating a condition where it's difficult for the driver to operate the vehicle. So this is what the system really shines under those conditions, where it requires less input or less torque from the driver, right, to maintain the course of the vehicle.
Yeah, so less of his physical effort. It's doing the physical effort.
So the reduction in fatigue and effort from the driver.
Exactly.
Perfect. Getting back to the presentation, if we take a look at the slide that we left off on, we were looking at the electronic architecture of the system, and it sounds really complicated, but I got to be honest, looking at it from this view, this topographical view where we can see DL1 and DL2 and the dedicated data link that's going between the electric steering motor and the gateway, this kind of really brings it all into focus. And I don't know about you, but it's really helping me understand how all of these components are connected together. So this is excellent. I really feel like I'm getting a good understanding of how the system works, where the signals come from, how the components are connected, and how they interact with each other. So I guess the next question that's on my mind regarding the front active steering system, when specifically, or I guess maybe this is but when specifically does the system become active? And Larry, I was wondering are there any specific conditions required for the front active steering to activate or become active on the vehicle? I wondered if you could just maybe elaborate on the conditions for us.
Yeah, there are a couple conditions or characteristics or behaviors of the system that we need to be aware of. And it's just the normal function of the system. When the vehicle is started, the system will activate as long as the steering wheels are not cut sharply to the left or right. Another condition that has to take place is the parking brakes must be released or the system will not activate. Another feature that is kind of a protection device is if you were at a railroad crossing or an extended red light, if you're not in motion for 90 seconds, the system will deactivate. Now, once you start rolling again, it'll kick back on, but that is another feature that is designed into the system.
And so when it deactivates and reactivates, right, sometimes we hear operators talking about like a slight feedback or something that they feel in the steering wheel, like they can very much tell. And maybe it has to do with the level of assist that the system is providing to them, but they certainly can sense, right, when the system is active and when it's not active. So again, it's important, I guess, to point out the wheels need to be straight ahead. Park brakes need to be released. I guess that makes sense to me as well. Why would you require, any sort of assistance if your park brakes are applied, right? So those conditions. Now, you mentioned a temperature range for the motor. Do we have any details we can share with the audience regarding the expected temperature range for this system?
Yes. During normal operations, the temperature shouldn't really be a factor. Where it could possibly be an issue is a vocational application, where this system is really struggling and working hard to fight the wheel feedback. So we do have temperature ranges. The system will deactivate at 257 degrees Fahrenheit or 125 degrees Celsius. But once the system cools back down, it will become active again. And that happens at 185 degrees Fahrenheit or 85 degrees Celsius.
Perfect. Thank you for that. So another, I guess, obvious observation on my part is the fact that when this motor is applying torque to the steering shaft, obviously the torque of the motor is going to create heat. We would expect this. All components on a truck, I guess, on some level have like a heat cycle that they go through, a warm up, a cool down. There's obviously values that we consider to be normal for normal operating ranges. And so this system is not unique in the sense that it has some thermal protection built into it. It can limit torque when the temperature values get too high. And obviously that's an important thing for the system to maintain reliability and performance. So thank you for sharing that. James, I'm wondering, as we go through this information, what does the system do when the vehicle is being operated or driven in reverse? Does it behave the same way that it does when you're traveling in the forward direction, or does it change significantly when we're operating the vehicle in reverse?
The FAS system is still in operation when we're in reverse. It's more of a return to center function than it is a torque to the effort of steering. So, when you're doing a maneuver and backing a trailer into a slot or at a truck stop, it's going to help you return to center. So it really does, because a lot of the times with the drivers, the effort is in returning the steering back under slow maneuvers.
Right.
So this helps in that.
Especially when you're trying to back a trailer into a dock, which is something that drivers do on a regular basis.
Oh, yeah,
right?
every day. Yep.
And it also, for me, I think back to a video, the slide that we just showed, right, obviously has an image here of Jean-Claude Van Damme straddling between two Volvo trucks that, if you've watched this video, they're traveling at a high rate of speed in reverse. I remember the first time I saw this video, I thought this was probably one of the most shocking pieces of advertisement I think I'd ever seen for any type of technology. And it stuck with me, and I wondered really how they pulled this stunt off with him straddling between these two trucks that are being operated in reverse at what I would deem to be a fairly high rate of speed for vehicles that are moving in reverse. So it clearly highlights the capabilities of this system, right? When a vehicle is in reverse, how it maintains the return to center, and it allows the vehicle to track straight when being operated in reverse, and it kind of answers a lot of the questions that I had about the video that we saw on YouTube. So I have to imagine at this point there's a lot of service managers and maybe service technicians out there that are probably wondering to themselves, like, what is required to service this system? And I just wonder, James, if you wouldn't mind sharing with us, for starters, are any of these components really serviceable or repairable?
Well, right now, they're not necessarily repairable. The steering motor, the electric steering motor itself, is offered as a reman item because of the size and cost, obviously. Nothing within that motor is repairable. Of course, you've got your ECU, you've got your dedicated link between this unit and the gateway on the truck. But any modification to this system and the torque sensors could really adversely affect function and safety of the truck. So we're limiting what we can do to R&R the motor, R&R the gateway, and the other units.
Got it. So really just, it's an exchange unit.
Yeah.
Obviously, some of the other components that we pointed out that are located in the cab of the truck, like the instrument cluster and maybe the gateway, some of those items I would imagine R&R, just like we do with any other component on the truck. And this electric motor assembly, clearly just an exchange unit. We don't want to open it or modify it in any way, shape, or form. It's just simply repaired as a unit.
Exactly.
Perfect. Now, you mentioned, or the slide, I guess, covered the fact that there's a neutral position for this steering gear. And so that brings me to another question I have. If there's a neutral position for this electric steering motor, I'm assuming there must be some sort of a calibration process required to kind of help maintain that neutral position, or to determine where that neutral position is from a system standpoint. And so, Larry, I was wondering, could you maybe elaborate a little bit on the calibration process?
Yeah, there are three main topics that we need to focus on. The first is the actual alignment of the motor itself. Then we need to look at the calibration of two sensors, the steering angle sensor and then the FAS sensor. So anytime we do things like replace control units, like the ABS or the FAS itself, anytime we change the motor, anytime we do any type of physical change to the alignment, adjust tie rods, caster camber, what have you, anytime any alignment has been changed, we need to follow this process.
And that's an interesting point, because alignments are a fairly regular, they're a common occurrence in the aftermarket. Steer tires are very expensive to fleets and customers. They want to obviously do all they can to make those steer tires last as long as they possibly can and get every last mile out of a steer tire. And so, they adjust inflation pressures regularly, and they also perform alignments on a regular basis to make sure that they're getting the most they can out of their steer tires. So I guess this calibration process is obviously going to be very critical then to making sure that they're getting all that they can out of these steer tires. How is the calibration performed, though? I mean, just kind of more of like, I understand the process and the sensors that need to be calibrated, but specifically the tools. What tools would a technician require to go through this calibration process?
We need to keep in mind that we're dealing with two proprietary components. So our steering angle sensor, that is done through Bendix software. The FAS sensor, that is proprietary to us, so that is done through TechTool. Use of Bendix ACOM, or if you have a J-Pro, there's a Bendix ACOM app in J-Pro. That is for the steering angle sensor. And we're going to use Premium TechTool for the FAS sensor.
Great. So ACOM is the Bendix software, and again, that's embedded into the J-Pro. We also have Premium TechTool for the front active steering sensor. The slide shown a moment ago alluded to a motor alignment visual inspection, and again, when we began this conversation about the calibration process, you identified that the very first thing was to visually identify the motor alignment. So James, would you mind speaking a little bit about this motor alignment inspection?
Yeah, the first step in any, if you have a customer with a complaint, steering wander, a pull, or something along that nature, the first thing to do is pull this truck into a bay. Get your steer tires pointed straight ahead, double check your steering wheel. But at this point, you want to make sure that you're also checking if you see any anomalies, say in your toe settings or anything like that, that these trucks need a physical alignment first. So, I mean, it's good to start this motor alignment check, but we have to start with a physically aligned truck first. That's the most important part.
So this calibration process then just kind of assumes already that the steering system has been properly aligned, right? Your toe in and caster and camber and all the angles that we typically look at during a wheel alignment. We want to make sure that those are all set properly before we go making any kind of an adjustment or calibration to the steering motor alignment, right? So that's first and foremost. And then are there, when we talk about alignment, typically, alignment marks come to mind. Are there any markings specifically on the motor, the steering motor, that would assist the technician with identifying whether or not the component is correctly aligned?
Right. The first check, or this motor alignment procedure, is we have to check the timing of the motor, and this is what I have here in front of me. This is what you'll see on the top of your steering gear, and there's several marks. We have a mark here on the input shaft, which is a small V groove. You'll also see a painted or a mark on this black cover that turns with the input shaft. And then you have the mark here on the steering gear housing itself. This is cast in place, and of course the V groove. These are the marks that are imperative to knowing if this motor is timed to a physically aligned truck.
So it sounds to me these marks obviously need to be inspected by a service technician, and we need to confirm that the marks are in the correct orientation before we move forward into this calibration process. So even before we're hooking ACOM or Premium Tech Tool to the truck, steering alignment needs to be correct, the alignment of the motor to the steering shaft needs to be correct, and then it sounds to me like we can take a look at the calibration of the sensors.
Yeah, if we talk about the alignment as we did before, pull this truck into a bay, you're checking your steer tires pointed straight ahead. Let's assume an aligned truck that you don't see any issues with tow or anything like that. Then you come to the motor and you check the timing of these two marks. If at that point these marks are not within 2 degrees, which is a very small amount, so let's just say if these are not pointing directly at each other, then we have an issue with what we haven't mentioned at this point is the drag length. This is what you'll see in this slide in the truck, in the engine compartment. It's a little tight, it's a little hard to see, but you can see the white mark on the collar and you can see the cast mark on the motor pretty well. A good double check is the V groove in the input shaft, obviously. So if you have an aligned truck, your steer tires are straight ahead, and these marks are off, at that point is when you want to look at your adjustable drag length to bring these timing marks back into alignment.
So just performing a quick adjustment at the drag length then to just kind of center.
Right.
Right.
You're aligning the motor to your physically aligned vehicle.
Perfect. Okay, once that has been established, so now we're dealing with a truck that has properly adjusted alignment angles, and we have confirmed the orientation of the steering motor. The next step then would be to calibrate the sensors. Now, forgive me, but Larry, could you remind me again, what was the correct order for the calibration of the sensors? I believe, if I remember correctly, was it the steering angle sensor first?
That is correct. Always calibrate the steering angle sensor first. Again, we're going to be using ACOM. We can use the ACOM application through the J-Pro to do this as well. One thing to keep in mind is during this calibration, we don't want that steering wheel to move. Once that sensor is calibrated, then we will use Tech Tool and we will calibrate the FAS sensor. A note about calibrating that sensor is during that operation, the steering wheel does move. It does rotate back and forth. So there's a transition time between when you're disconnecting ACOM and hooking up Tech Tool that you need to pay close attention that steering wheel isn't moving.
Perfect. So the order of this process sounds really important to me. It sounds like it's a critical thing for technicians to understand the proper order that these steps need to be completed in. And so we have an image that we could show the audience. It's actually from Premium Tech Tool. This was a screen capture that we took while we were in the tool. And this is showing Premium Tech Tool. We're looking at the calibration tab. We're under function group 6, and we find this operation listed here called active steering. Operation number is 6476-07-03-01. And this is basically where a service technician would go, right, to perform the calibration of this front active steering sensor in Premium Tech Tool, right?
Yep.
And then as we step forward into this process, it looks to me as though Premium Tech Tool actually prompts the technician to perform the steering angle sensor calibration using Bendix ACOM software or Bendix ACOM calibration. It's there, one of the first things, and it is actually telling the service technician steering angle sensor must be calibrated with the Bendix ACOM diagnostic tool before proceeding. So that's kind of cool that the tool does that for us, right? It prompts us helps us remind us of the correct order in which these need to be calibrated. So with this information being placed in Premium Tech Tool and the routines are in the tool to support the calibration process, I guess one of the other questions that I have, and Larry, I'm going to kind of throw this at you. Is there anything specifically that you can think of that might cause this calibration process to fail? I'm sure there's a lot of service technicians out there. You know, we always talk about when things go correctly or when things work the way that they're supposed to, but what about the situation or the scenario where maybe they try to run through this process and the calibration just simply doesn't complete successfully? Is there anything that we should alert them to or anything that they should check while performing this calibration process?
Yeah, as I touched on before, Dave, during the calibration of the steering angle sensor, again, this is up to the technician. It's his responsibility. We do not want that steering wheel to move. If it does, that will definitely cause that sensor calibration to fail. A lot of procedures in alignment shop, while they're doing the physical alignment, they will actually secure that steering wheel in place. Again, you got to pay close attention to the details. We do not want that steering wheel to move when we're calibrating the steering angle sensor. And the exact opposite when we're calibrating the FAS sensor. That has to move. The steering wheel will physically rotate. A lot of guys are shocked when they push the activate button and they see the steering wheel starting to rotate. That is supposed to happen. If you interfere with that in any way, that will also cause that calibration to not be effective.
Yeah, it's kind of an unexpected response from the system when you calibrate the front active steering sensor, right? The steering wheel, the motor will actually turn the steering wheels, right, in several degrees in each direction, which obviously causes your steering wheel to move quite a bit during the process. And you also bring up a really good point. I can think back to my time in the alignment bay as a technician. You know, you secure a steering wheel while you're making adjustments to the steering linkage, right? Because you want to maintain that setting for the steering wheel while you're adjusting the steering components to match that steering wheel setting. And so it's going to be important for a technician working in an alignment bay to remember to free that steering wheel before they perform the calibration of the front active steering sensor, because obviously that could cause the operation to fail if the steering wheel is not allowed to move freely. So since we're talking about Tech Tool and we've mentioned calibration failure, I guess it leads me to another question that's on my mind, and it was mentioned or actually asked earlier in the presentation, and I promised the individual who asked the question that we would get to this part of the presentation. What happens specifically when there is a fault or failure in the front active steering system? James, I wonder, could you expand on that question or that thought for us?
Yeah, we have different types of faults that we can have. We can have electric motor failure. We can have data link connectivity issues. We can also have alignment issues. And in each system, via Mac or Volvo, you're going to see a pop-up in the driver display, telling you one of those three types of situations. So you'll see the exact front wheel alignment issue. If the motor is sensing whether it has to compensate too much for a given situation. We also have command steer or Volvo dynamic steering disabled. That would be more along the lines of a data link or a electrical error. And then you also have missing communication, which would be a direct data link error. But what I want to make sure I emphasize to the guys in the audience is that you may lose function of the electric steering system, but you do not lose the hydraulic system. Like I said in the very beginning of this, it's an overlay system, and it helps the hydraulic take away the driver fatigue. You don't ever lose the hydraulic system except given a hydraulic fault or something along those lines, which most technicians already are aware of, given individual situations.
Yeah, that's probably a really important distinction, right, that everybody comes away from this presentation with, is that this system really is an overlay system. So if it fails in any way, shape, or form, like a good comparison to me earlier, we were discussing the system, ABS, for example, right? When you have an ABS failure, you don't lose the ability to stop the vehicle. You just simply lose the ABS feature of your brakes. The vehicle will still stop using the braking system. And so in this instance, we still retain power steering. We still have the hydraulic assist and all of those features on the truck. The driver just simply loses the active steering feature of the vehicle, right? But he
loses that extra torque.
Really all. So the added torque from the system is really all that they lose. So at best, it goes back to steering and operating like a vehicle that doesn't currently have this system. It would just be like any truck that they've ever driven before.
Correct. Yep.
So hopefully they don't get too spoiled by this level of assist, right? Because they'll forget what it feels like to drive a truck without it. We're getting a lot of questions from the audience, and so I don't want it to be alarming, but we've placed a microphone. As you can imagine, there's a large support team in here helping us with today's production. We have audio and visual, and so we're going to hear from Amanda Clarida, who is the manager of our learning, design, and development team. She's in the room with us today. And Amanda is going to be, she will read some of the questions that have been presented by the audience. We'd like to just take an opportunity to acknowledge those questions and maybe answer some of them quickly if we can before we move forward. Amanda?
Yep. Can you hear me? Okay, how's that? All right, great. So yeah, there's quite a few questions here. The first is, what happens if you have an electric motor failure?
If you have an electric motor failure, you're still going to have the hydraulics system intact. Obviously, if you have an electric motor failure due to a crash situation, you may lose both. But if it's just an electrical failure, you still have hydraulics.
Awesome, thanks. What's our plan for after this presentation? There are a couple questions about printouts that are going to be available. Are we recording and sending this out, and are we going to make this slide deck available as well?
Yeah, so I should have mentioned all of these Academy Live broadcasts are being filmed, and so we're in the process. It's live. You're consuming this live as it's being broadcast, but we're also recording these. And so if you go onto the Trucks dealer portal and you navigate to the training tab, under the training tab you will simply find a new header there that is called Academy Live. And when you click on the Academy Live link, you will find a list of all of the Academy Live broadcasts, and it will allow you basically to watch any of these presentations that we've conducted so far. So it's kind of in its infancy. It's a new thing that we've started doing here within the Trucks Academy. But as we get more of these completed, obviously that list will grow over time, and it should eventually turn into a great resource for you to go and kind of recall and review previous topics that have been presented. And these topics, by the way, cover a full range, anything from sales to parts to service, warranty. You will find a wide range of topics that are going to be covered by these Academy Live presentations. And so we really hope that you find value in these presentations and that you're able to kind of rely on them or go back and refer to them in the future.
Okay, thanks, Dave. There's a question about the appearance. What will a DTC, how will it appear if it is a mechanical or performance and not a data link issue?
Okay, so we still have more slides in the presentation to get to. We do have some that will kind of show what happens when there's a fault or a failure. In fact, we're actually just a few slides away from that right now, but there are messages that are broadcast to the driver that will simply alert them to the fact that there's been a system malfunction. And it even identifies the messages that are displayed on the instrument cluster are very specific, I guess, to the type of failure that has occurred. But then obviously within Premium Tech Tool, James, I'm assuming like when a technician plugs in, kind of like any other system on the truck, there's going to be codes, I would imagine, that will be displayed in Tech Tool, and the technician can use those codes as a reference.
Yeah, you'll see there's several DTCs that are added for this system. Now, if I hear that question correctly, it was a performance issue versus a failure? Okay, so you're probably not going to get a DTC if it's a performance issue. Say, if I'm only getting half of the torque that I think I should be getting out of the system versus no torque at all. So we don't have a DTC for performance necessarily. You would end up getting the message in the DID for either the system disabled or the communication failure or an alignment issue. Like I mentioned, if the system is trying to overcompensate more than it normally does or in a normal situation, then it's going to give you an alignment issue. Say vehicle alignment is bad. It's assuming that it's vehicle alignment, but it could be obviously a performance with the motor. So.
Thanks, Jim.
Yep.
There are quite a few questions specific to data links. Data links 1 and 2 is being referenced, and then some of the J codes that were referenced before. So do you want to move on to the rest of the presentation, or do you want to take those now?
Yeah, we'd like to, just in the interest of time, we're running a little long. I want to get back to the presentation just to ensure that we're able to cover those materials. We'll circle back. Listen, all of you that have submitted questions to us, we have a log. Okay, we're able to see that we've captured all of those questions. Obviously, that's how Amanda is reading those for us. So we have those questions available. We will try to answer as many of those questions as we can. After the presentation is concluded, we have the ability to send answers out to those of you that are participating today. And also, questions have been asked about the slide deck that's being utilized in today's presentation. And I will confirm whether or not we will be able to share that with you. But if that is a possibility, we will make that happen. I will try to make this available for everyone who's on today's call. So, again, as mentioned previously, there are some messages that will be displayed on the instrument cluster. So we have some examples of what those might look like. On the screen right now are the messages that are specific to the Mac command steer system. And so you can see when the system's been disabled. There is, in fact, a fault code that will alert the operator when there's a wheel alignment issue with the vehicle. And then obviously there's a message that indicates when communication is missing from the command steer ECU, which again is critical. And the same messages exist for the Volvo dynamic steering system as well. We can see when the system has been disabled, when there's a front wheel alignment issue, and when there's missing communication from the front active steering system. So again, great questions from the audience. We appreciate that. Speaking of disabling the system, on a previous slide, we talked about wheel alignments. You kind of, referenced making wheel alignments, and we were kind of approaching that scenario as if the wheel alignment was being performed in-house. But I mean, I know for a fact that there's a large percentage of our dealer population that sublet wheel alignments to a third party to have them completed, whether it's a tire shop or an alignment shop that's local. They probably have a relationship with them. They use them all the time. So they sublet this out to a third party to have the wheel alignments performed. How does a third party wheel alignment shop handle this calibration? I mean, like, what do you tell your alignment guy when you send a truck over there with this system on it?
Yeah, so this may be, this is a new feature, a new system in the marketplace, and this may be one of the bigger things that we deal with this system. So if you send out your trucks, you notice a customer has a complaint, it's got a wanderer, pull, etc., and you're going to get the truck physically aligned. You know at that point that you've got to do these calibrations, ACOM and our tech tool. So the wheel alignment shop, we'll have to instruct them, obviously, to pull fuse FE24, which is in the engine compartment fuse panel. So they can do the physical alignment, get it all right, pull the fuse, and then whoever's driving the truck, be it the shop, your shop, a tech, so they're not subjected to a pull where they're going to be surprised by a pull that fuse and it disables the system. So then they can drive the truck under standard hydraulic power back to the dealership. Then you reinsert the fuse, and then you go through your alignment procedure. Pull it into a bay, make sure your steer tires are straight ahead, check your timing marks on your motor, and then go through with the calibration procedure.
Perfect. So imagine there's probably some service technicians and service managers in the audience right now that are wondering, this fuse FE24, it's in the external fuse and relay center under the hood. Are there any other instances where removing this fuse, which will cause the system to be disabled, are there any other instances where that might be a useful thing for them to be able to disable the system? Like, is that advantageous to them in any way, shape, or form? Again, James, I'm going to throw this question your way if you wouldn't mind.
Yeah, absolutely. We use this as a root cause analysis or diagnostic tool, right? So customer complaint, truck pulls. How do you know it's the system versus the steering? So pull that fuse, go drive your truck, do a test drive. If that truck drives straight ahead and is good, then you know it's likely the system, the FAS system, versus the physical alignment of the truck. So it's a great diagnostic tool for that reason. You can separate the two systems, diagnose, and move on from there. Which system you think needs to be repaired?
So it really gives them the ability then to kind of isolate and find the root cause of the problem, right? Because there's a lot of things that can cause a vehicle to pull. It might have a steer tire that's causing it to pull. It could be an alignment angle that's out of spec. It doesn't always have to be the most complicated thing on the truck, which we have a tendency sometimes to want to go to that place, right? But so we can pull the fuse, drive the truck, make sure it goes straight, right? It isolates whether it's an actual alignment pull or whether the system's creating a pull.
And conversely, if you ever have a truck that has VDS and the guy says all of a sudden it doesn't work, check your fuse first.
True.
Going back to basics.
True. Keep it simple, right? Keep it simple. That makes sense. And so diagnosis and isolation of root cause, these are all things that we preach at Trucks Academy classes. We want technicians to obviously follow our published procedures. And that brings me to my next question. And I'm going to throw this one Larry's way. Larry, is there any information available or published within Impact that supports this front active steering system? Is there stuff available for technicians to find today?
Yes, Impact has been updated as this product was released. There are design and function documents, which I always find useful, that explain how the system works in a little more detail. There is a procedure released specifically for alignment on a vehicle that has active steering. And again, use Impact as your primary source for service information.
Perfect. And there's a great list right there, right on the screen of the identity numbers that are available within Impact. So we're kind of nearing the end of our time today. We've blocked out a 1 hour time slot in an effort to be respectful of everyone's times. Can we just quickly recap what are some of the key takeaways or key items to remember? And James, you want to just kind of recap some of the important things that we covered in today's presentation?
Sure. I guess the first thing I want to make sure that our techs and dealers understand is we don't want to just be parts replacers. We want to think this through, right? So let's check our motor shaft alignment and make sure we have calibration set, first of all. We want to know that the truck is physically aligned, right? That's a basic. We should do the physical alignment first. So pull the fuse, isolate the system, make sure your truck is aligned, then go back and look at your electric motor timing marks. Make sure that they're within the 2 degrees that I mentioned. It's hard to see 2 degrees, so let's make sure those marks are aligned. Then we want to make sure that we have performed our calibrations in the right order. If we're still getting faults and our system's not working after we've gone through all this effort, let's make sure that our Bendix ACOM was used for the steering angle sensor first, and then the torque angle sensor or the FAS sensor was done with PTT second. It's got to be in that order, like we said and Larry mentioned previously. Use that fuse pull as your diagnostic tool. I mean, it's simple, so let's use that. And then obviously you want to, if you're sending your trucks out for the physical alignment, you want to make sure that you're pulling that fuse to bring that truck back under hydraulic steering only until you guys at the dealership can do your proper calibrations.
Perfect. Thanks for that, guys. Lastly, I just want to draw everyone's attention to the fact that there are some amazing videos that have been put together by our sales and marketing organizations for each respective brand. And if you go out to the YouTube channels, if you just do a basic search for Mac Command Steer, you will be presented with some amazing video content that really shows the system in operation with a driver in the truck, and it kind of highlights the driver experience. These videos are a tremendous resource for understanding exactly what the system is capable of and kind of how it functions. I know today we dug into a little bit more of the technical, what goes on behind the scenes, but these videos are a great resource for not only service technicians, but service managers, service advisors, both, right? It will help you understand the experience that the driver has while operating a vehicle with the Mac Command Steer or the Volvo Dynamic Steering. Again, on the Volvo side of the product, if you go to the YouTube website and you pop in Volvo Dynamic Steering as your search criteria, you will be presented again with a bunch of videos that highlight the way this technology is integrated and functions on the Volvo product. So I would encourage all of you to kind of take the information that you've gained today, build on it, enhance it, go forward with it. Go to YouTube, consume some of these videos. I think it will really help drive your understanding of the system even further. And so that's all the time that we have for today's edition of Trucks Academy Live. I really hope that you found today's session to be interesting. I hope you found it to be informative. And we look forward to having you join us for future presentations. Again, this is something we'll be doing on a regular basis, covering a broad variety of topics. You can find registration links on Trucks Dealer Portal. There will be banners posted and bulletins under the training tab with registration links that will allow you to click and register for the events, which again gives you the ability to attend these. And I want to thank you for your time. And until next time, this is Dave, Larry, and James saying so long. Stay safe and stay healthy. Thanks again.